Spintronics and Mram, The Future of Electronics by AZLAN ADNAN, M.A. Sunday, 8th of December 2025. Introduction. Modern electronics rely almost entirely on the charge of electrons to process and store information. Traditional semiconductors, such as CPUs, GPUs, and flash memory, use the movement of electrons through silicon circuits to encode data as ones and zeros. Spintronics, short for spin electronics, introduces a new dimension, the electron's spin. Spin is a quantum property that can be imagined as a tiny compass needle pointing up or down. By harnessing both the charge and spin of electrons, spintronic devices promise faster, more energy-efficient computing. What is MRAM? At the heart of current spintronic applications is MRAM, or Magnetoresistive Random-Access Memory. Unlike conventional RAM, which stores data as electric charges and capacitors, MRAM stores information magnetically. Each memory cell contains a thin magnetic layer whose orientation encodes a bit. Up for 1, down for 0. Reading the bit involves detecting how electron spins interact with the magnetic layer, consuming far less energy than moving charges through a transistor. Writing data involves flipping the magnetic orientation using small currents, or spin-polarized currents. How spintronics differs from traditional semiconductors. Spintronics differs from traditional semiconductor technology in several key ways. It adds a new state variable, spin, rather than relying solely on charge. This allows non-volatile memory. MRAM retains data even when the power is off, unlike DRAM or SRAM. Spintronic devices can operate at lower voltages and produce less heat. They also have the potential to combine memory and computation in the same device, reducing the energy and time wasted moving data between memory and processor. Advantages of Spintronics MRAM is extremely fast, rivaling SRAM in speed while offering non-volatility. It consumes less power, especially in standby mode, which is critical for battery-powered devices. MRAM is highly durable, with write endurance far exceeding flash memory, making it attractive for embedded systems and data centers. Spintronic devices can scale down to nanometer dimensions without losing performance, promising continued miniaturization beyond the limits of conventional silicon. Drawbacks and challenges. Fabricating consistent magnetic layers at the nanoscale is complex and expensive. Reading and writing spins reliably requires precise materials engineering and advanced interfaces. Currently, MRAM is more costly per gigabyte than DRAM or flash, limiting widespread adoption. While MRAM is fast, it does not yet fully match the ultra-high-speed cache memory in CPUs for all applications. Moore's Law and Spintronics. A critical question is whether spintronic technology will continue to follow Moore's Law, which predicts transistor density doubles roughly every 2 years. Spintronics is less dependent on transistor scaling because it leverages quantum properties. In some ways, it represents a post-Moore paradigm. Instead of relying on smaller transistors, engineers exploit new physics to increase efficiency. MRAM and other spintronic devices can scale differently, potentially sidestepping the classical limitations of silicon miniaturization. Physical limitations and future prospects. Thermal fluctuations can disturb tiny magnetic orientations, imposing a practical lower bound on memory cell size. Quantum effects and material imperfections may slow the pace of miniaturization. Despite these constraints, spintronics could dominate certain memory and logic markets for decades. MRAM is already deployed in automotive electronics, IoT devices, and data centers. A widespread spintronics wave could reasonably last 20 to 30 years, with ongoing hybridization alongside conventional semiconductors. Conclusion. Spintronics and MRAM represent a quiet but powerful revolution in electronics. By exploiting both charge and spin, they offer faster, more energy-efficient, and non-volatile alternatives to traditional semiconductor memory. Fabrication challenges and costs remain, but the potential longevity of spintronics, coupled with its scalability and efficiency, makes it a transformative technology. The coming decades may see a hybrid computing world where silicon and spin coexist, reshaping personal devices, data centers, and computing architecture itself. Spintronics is no longer a lab curiosity. It is entering practical use today, and MRAM is just the beginning of a new era where electrons do more than move, they spin. Learn to cook with confidence. a holiday cooking experience for teens and school leavers. Cooking is one of the most important life skills a young person can develop. We eat every day, and knowing how to prepare good food sets you up for independence, creativity, and lifelong well-being. In my holiday cooking classes, I go far beyond teaching recipes. I blend knife skills with the wonders of food science, the chemistry, biochemistry, and nutrition that shape every flavor, texture, and aroma. It's the practical, delicious side of the science you learn at school. My sessions are fully hands-on. You will feel the warmth rising from a pan, hear onions sizzling into sweetness, smell butter turning nutty and golden, and watch simple ingredients transform into something extraordinary. Cooking becomes a sensory adventure, not a chore. To ensure every student gets dedicated attention, I keep each class small, just 3 to 6 participants. We learn by doing. We taste constantly. We experiment with confidence, and we uncover why small changes in technique make big differences on the plate. Classes are held by appointment throughout the December school holidays. Each session gently builds confidence, skill, and curiosity as students work from raw ingredients to a finished dish they can proudly serve at home. And here's something parents love. My class fees are by donation. If your child walks away bored or unmoved, you pay nothing. But if your child returns home excited, inspired, and perhaps presents you with a classic French onion soup, richly caramelized and impossibly fragrant, then simply contribute what you think that experience is worth. If your child keeps pestering you to bring them back for more classes, well, you'll know you've got your money's worth. All proceeds help fund my ongoing eye treatments, so every contribution goes to good use. Students will also learn how to choose fresh ingredients and shop smart. Do give them some grocery money, because selecting produce confidently is just as important as cooking it well. If you're ready to turn curiosity into skill and skill into joy, I would love to welcome your teen into my kitchen. Parents are most welcome to sit in as chaperones or return at the end to savor their children's culinary creations.